Hello, my name is Inohara, and I'm taking this video on my laptop because my upload video has been uploading for quite a long time, and I'm not sure if it's going to upload. But if you upload on your computer, then you can get the link before it uploads. So I will do it like this. So problem was let me read it, to sketch a trajectory of a simple harmonic oscillator over the course of one period on the phase-space plane. The y-axis of velocity rescaled by the square root of half the mass, and the x-axis of position rescaled by the square root of the spring constant over 2, and explain the trajectory on subsequent periods. So then when I looked at this, I didn't really know what to do, so I went to Slack, and they said, it's a circle, and I thought about it, circle, and then I was like, he said use the fact that these, so the x and y axis counted as a hint. So I was like, maybe it's the energy equation, because that relates the velocity and the position kind of into the energy, right? But first, that's after I figured out his circle because of what he posted. So then I started thinking about it so then I drew my circle, and then obviously just looking at the circle, you already know that when your x is 0, your velocity is greatest, and when your velocity is 0, your x is greatest, right? So then let me explain this in the ways that I kind of understood it before I even started looking at equations. So this is like a pendulum, right? So it's moving up and side to side. So x is equals 0, right? So say your x equals 0 right here. And then when you move it, now your x is changing, but every time you get here, your x is 0. Right? So when your x gets to 0, your velocity is going to be greatest because you're coming down, x is 0, you start going back up, you slow down a little bit, and eventually you get here, you stop, you come back down, x is 0, right? So velocity is greatest there. And then your x is going to be greatest when your velocity is 0, because think about it, again, like a pendulum. When you go up to here, up to this point, your maximum, you stop for a little bit. You stop for a brief second before you start going back down. So you stop, move, stop, move, stop, move. Right? That's how I thought about it. But then when you use the energy equation, you set your x equal to 0 for that. You get your velocity is equal to square root of 2. 2 times your energy over k, and then set your velocity equals 0. You get square root of 2 energy over mass. Over k. And then velocity, it's 2 energy over m squared. So when you do all that, that's basically how you kind of get it, how you start to think about it. And then I was looking at it, I was like, I think that's how a circle would look like, or an ellipse. I'm not sure. I never actually graphed it. But hopefully my non-mathematical explanation helped you out. And then, so part B was to sketch a trajectory of the same plane for a damped harmonic oscillator over the course of multiple periods, right? So just knowing these equations from the back of the book, back of the chapter, you know that when you start damping, your energy goes down exponentially, right? When you start looking at this equation. So your energy starts going down exponentially, and then as your energy goes down exponentially, your amplitude also starts going down. Your waves get smaller because your amplitude is going down, right? Your maximum height's going down each time because your energy is decreasing. And then your time constant, so you see where the time constant comes into play, right? It's t over time constant, and it's the exponent of that, the exponential. And then this equation is used for this graph, showing your amplitude. But it shows how energy and the amplitude is related. So the more damping you do, the less energy you get. So you add damping, you start going down. So then I was looking at this, right? And then remember, I don't know if I mentioned that when you start looking at this as a circle, you can really kind of think about it as you move the circle to a flat plane, and now you're looking at it head on, not from above. You just see your object. It starts as looking like this, which is kind of like a horizontal spring or horizontal oscillator. You look at the circle from the side, and now it's going up and down, and now it's like a vertical oscillator, right? So then that's really what this is right here. So then based on that video I saw, I was like, okay, well, this is a circle then, and I want to take it smaller. I think about it just like a different view. So this is getting smaller, so now your circle is getting smaller as you have damping, and that's kind of how I did the problem, or how I thought about it. Any questions? And just Thank you for your time.